So let's look at some examples of literal equations where we're given standard form and we need to solve for y, which would put our equation in slope-intercept form. So just real quick, let's remember that standard form of a linear equation is where we have ax plus by is equal to c. Right? A and b are called coefficients and c is called a constant. And if you'll remember slope-intercept form, that's the form that we've dealt a lot with graphing. That's our y equals mx plus b, where m represents our slope and b represents the y-intercept, which is why it's called slope-intercept form. Right, so there are some positives of standard form and some positives of slope-intercept form, so it's nice to be able to go back and forth between the different forms depending on what it is you need to find. So in our equation here, it's in standard form. We have 3 times x plus y equals 10, and our job is to get y by itself. Again, there's an understood addition sign in front of that 3x. And so to get y by itself, we need to do the opposite of this plus 3x, which would mean subtracting 3x from both sides. And the reason that we subtracted is because 3x minus 3x is 0. So we are left with just y equals, and on the right-hand side, we can't combine these like terms, so we subtract. Now, slope-intercept form, we typically like to have the slope first, so we can rewrite this as y equals negative 3x plus 10. And just as an added review, let's identify the slope. The slope of our equation here is that coefficient in front of x, which would be negative 3. And then let's also identify that y-intercept. Right, and that's our constant at the end, which we like to write as an ordered pair 0, 10. All right, let's look at an example that's a little bit harder. So here again, we're trying to solve for y, and our equation is in that in standard form, right? Ax plus by equals c. And in trying to get y by itself, we need to get rid of the 4x. The 4x has been added, so we need to subtract the 4x from both sides, because 4x minus 4x is 0, which leaves us with negative y equals 3 minus 4x, which we can also write as negative 4x plus 3 if we want it to really be in that slope-intercept form that we're used to seeing. Now here we have to be careful. While it looks like we have y by itself, we don't fully have y by itself yet because of this negative out front. That negative really gets in the way, and we have to pay attention to that. So if we want to get rid of the negative, we can think of this as negative times y. So if we want to undo that multiplication, we can divide everything by a negative 1, right? Because there's that understood coefficient of a 1 in front. So negative 1 divided by negative 1 leaves us with y. And here we want to treat each piece individually. So we're going to start with that negative 4x divided by y. All right, so divided by negative 1. So negative 4x. Find my pen, it disappeared on me. Negative 4x divided by negative 1 gives us a positive 4x. Oh, get rid of that. My mistake there. And then we can also look at 3 divided by negative 1. which is -3. So in slope-intercept form, we have y equals 4x minus 3. All right, let's look at another one. So here we have a few more coefficients. We have 2 times x plus 7y equals 14. And again, we're trying to get y by itself. So just like in the other examples, we need to get rid of this 2x. The 2x has an understood addition, so we're going to subtract 2x from both sides. And we did that because 2x minus 2x is going to cancel out, which leaves us with 7y equals 14 minus 2x. Or we can rewrite this so that the x term is in front with negative 2x plus 14. Now, we have still this coefficient of 7 that we need to do something with, right? So this is 7 times y. So to undo that multiplication, we are going to divide both sides by 7. And if we do something to one side, we have to do it to everything on the other side. Not just one piece, but all of them. And so we did this because 7y divided by 7 is leaving us with just y. And now we want to take a look at each individual term and see what happens. So here we have to look at the negative 2x divided by 7. Negative 2x divided by 7, and we can't simplify that, so that's going to give us just, oh, my mouse is going a little crazy over here, it's going to give us negative 2/7 x. And then we also need to look at the 14 divided by 7. And so when we take a look at that piece, the 14 divided by 7, that gives us plus 2. So in slope-intercept form, we have y equals negative 2/7 x plus 2. All right, one more for good measure. Here we have 6x minus 5y equals 10. Again, there's that understood addition, so we need to subtract 6x on both sides, which is going to give us negative 5y equals 10 minus 6x, which we can also rewrite as negative 6x plus 10. And just like in that last example, we still have a coefficient on the y that we need to get rid of, and it's being multiplied, and we can undo that multiplication with division. So when we divide both sides by 5, we have y equals. And again, we want to look at one individual term divided by the denominator at a time. So here we can look at negative 6x divided by negative 5. The first thing here to note is a negative divided by a negative gives us a positive, but we can't simplify 6 divided by 5, so it can just stay 6 divided by 5, or 6/5 x. And then we also want to look at what we get when we do 10 divided by negative 5. Be careful here, pay attention to those signs. We get minus 2. There you go. That's from standard form to slope-intercept form.